Alrighty. So in example one, we want to find the domain of the following functions. Part A states f of x equals 5 over x minus 7. Part B states g of x is equal to x squared over x squared minus 16. And part C states h of x equals x minus 5 over x squared minus 7x plus 10. So in short, if you want to find the domains of your functions for these given functions, just know that these are rational functions. And with rational functions, you exclude the values of x that makes the denominator 0. Okay? So in short, rational functions, I'll call it R of x, is usually written as one function over another, right? You have a function that's in the numerator, so I call it n of x, and you have a function in the denominator, we call it d of x. So that bottom d of x can never be equal to 0. Why? Because your pre-calculus professor, or whoever you learned this from, tells you that you cannot divide by 0. Okay? So to figure out the domain of each of your functions, first find those problematic inputs. Set those denominators equal to 0 and solve for x. For example, in part A, when we have f of x equals 5 over x minus 7, if you just look at your denominator, you can do this intuitively. What value of x makes that bottom 0? Right? Think about the equation. X minus 7 equals 0. What would x be equal to? 7. X is equal to 7. So this function is valid for all real numbers except 7. Right? So in plain English, we say that our domain is all real numbers except when x is equal to 7. Visually, if I look at this on a number line, let's say here's my real number line. Let's say here's 0 as my placement. And we know 7 is to the right of 0. Well, above our 7, we can plot an open point, and our domain now is any value of x that I can choose, except that open point. So let's think about it. I had one problematic input here. Since I had one problematic input value, then your domain is no longer the entire real number line, but in fact is broken into two sub-intervals of your real number line. What we're going to have is that if you use interval notation, your domain goes from -infinity to 7. That's everything to the left of 7, right? I could have chose a value here. I could have chose a value here, 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 right? All of this green stuff here is -infinity to 7. Now, we want now anything to the right of 7, so we use a union symbol, and we say 7 to infinity. All right? And that's your domain. You express your domain in words, in a picture, and interval notation. But notice, when you had one problematic input, how many intervals you had to write? You write 2 intervals. All right, let's try it again in part B. In part B, it states that g of x is x squared over x squared minus 16. Again, all we care about is just figuring out the domain of our function. So because our function is a rational function, we got to look for what values of x makes this denominator 0. Whatever values of x makes that denominator 0, we pull them out of our domain. So let's write out the equation. X squared minus 16 equals 0. All right, now for this equation, x squared minus 16 equals 0, you can solve it using factoring techniques. The factoring technique that we can use is the difference of 2 perfect squares. The difference of 2 perfect squares, this is just a little side note, states that if you have a term that's squared, let's say a squared minus another term squared, b squared, hence difference of 2 perfect squares, it's equal to a plus b times a minus b. All right? So think about it. You have x squared. Well, what squared gives you x squared? Just x, right? Now, what's squared? A number squared that gives you 16, 4, right? So if you use this format, this is x plus 4 times x minus 4 equals 0. And you split this into two equations. If you split this into two equations, you get x equals -4 and x equals +4. So those are your two problematic inputs. X cannot be equal to either one of these numbers. So we could just simplify it and say plus or minus 4, right? In words, your domain is all real numbers, except when, right? So this is just writing out in a sentence. Domain is all real numbers, except when x is equal to plus or minus 4. And we can also say that when we look at this visually on a number line, say here's 0, say here's -4 and 4. At the -4 and 4, I can plot open points, and I'm drawing a line segment that essentially, or line that just bypasses these 2 points. Now be careful, when I draw this line, that particular line breaks the real number line into how many parts? 3, there you go. All right, so every time you tack on another problematic input, you have one more interval to write, right? So for example, when I had one problematic input, we had 2 intervals. Now that I have 2 problematic inputs, you now have 3 intervals to write. The first interval that you write, when you're doing this interval notation wise, is anything to the left of -4. So as an inequality, that means x less than -4. So this is from -infinity to -4. Union, anything now between -4 and +4. So we say -4 to 4. And then lastly, anything that's bigger than 4. So x is greater than 4. That implies 4 to infinity. And that is your interval notation for part B. Sounds good? All right. Ready to move on? Let's look at part C, and then I'll answer your next questions. So in part C, we have h of x was given as x minus 5 over x squared minus 7x plus 10. So as I mentioned in the earlier, you're trying to find the domain of your functions. The first thing is look at your denominator. Your denominator is going to contain values of x that makes that bottom 0. Now, since our denominator is a quadratic, when you set this quadratic equal to 0, you have a quadratic equation. One way of solving the quadratic equation, again, is factoring, all right? So you have x squared minus 7x plus 10 equals 0. What are two numbers that when you multiply them, that gives you positive 10 that adds up to -7? Two numbers that multiplies that give you positive 10, yet they add up to -7. 5 and 2. Now, what do we know about those 5 and 2? Are they going to be positive numbers or negative numbers? They're going to be negative, right? The 5 and 2 must be negative because the middle term was negative. Okay, so you have x minus 5, x minus 2 is equal to 0. When you split this into two equations, we get x equals 5, x equals 2. Therefore, x cannot be equal to 2 and x cannot be equal to 5. If you write this in words, we say domain is all real numbers except when x equals 2 and x equals 5. If I look at this from a visual point of view on a number line, say here's 0 again, say here's our 2, and let's say here's our 5. Above the 2 and 5, you plot open points, and you draw your line. But Is my line going through the open points? No, they just bypass them, right? When you draw your line, the line doesn't go through the open points, but it just bypasses them, right? So we start from the left here. Bypass that open point, bypass this next one, and there you go. If you look at it now, your domain now is split into how many parts? Split into 3 parts. The first part is anything to the left of 2. So mathematically, we say x is less than 2. The second piece will be the middle, anything between 2 and 5. So as an inequality, it's 2 less than x less than 5. And the third piece is now x is bigger than 5. Each of your inequalities you can write as a interval. X less than 2 implies negative infinity to 2. Union 2 to 5. Union 5 to infinity. And that is your solution. All right. That's how you essentially find a domain for these types of rational functions.